Okay, we're going to look at some grade 12 trig identities. Okay, now remember from grade 11, a trig identity is when you have to prove the left-hand side equal to the right-hand side. Okay, so we usually pick the harder looking side and we work with the harder looking side and see if we can get it equal to the other side. But sometimes we have to work with both, okay? Remember our general clues on this, okay, is that if we're adding fractions, adding or subtracting fractions, that we find an LCD, okay? All right, an LED, an LCD. Remember that if we've got that we have to sometimes factorize. Okay, remember difference of squares and those sorts of things that we have to be able to do. Okay, and yeah, I think those are the sort of things you have to remember from last year, okay? But let's look at those that are applicable to grade 12. And now they're obviously going to include double angles as well, okay? So, for example, they might say to you, prove that sine 2x all over cos 2x plus sine squared x is equal to 2 tan x. Okay, so if I look at this, my left-hand side looks more difficult. So I'm going to work with my left-hand side first. So my left-hand side is equal to, all right, sine 2x, I know is a double angle. I know it's going to become 2 sine x cos x. Okay, cos 2x is also a double angle. Now remember, I've got three options when I write it. I could have cos squared minus sine squared. I could have 2 cos squared x minus 1, or I could have 1 minus 2 sine squared. But I'm going to choose the first one. Why? Because it's going to have a negative sine squared x. So I'm going to rewrite this as cos squared x, okay, minus sine squared x plus sine squared x, because then you can see that those are going to cancel, okay, and then cos x will cancel with one of the cos x's, and I'm left with 2 sine x over cos x, which is equal to the tan of x, which is equal to the right hand side. Okay, let's do another one. This one, they want me to prove that the sine of 3x is equal to 3 sine x minus 4 sine cubed x. Okay. All right, so both sides look fairly difficult to me, okay? What I do notice on the left-hand side is I've got sine 3x, which I haven't really come across before. But I know that I could rewrite that. So I'm going to say on my left-hand side, I'm going to rewrite sine 3x as sine of 2x plus x, okay, which is now going to be a compound angle, agreed? It's going to give me sine 2x times cos x plus cos 2x times sine x. Okay. All right. So now I know that the other side is only in terms of signs. So I'm going to carry on with my left-hand side and see if I can maybe... Sorry, you got the dogs barking. So I'm going to carry on here and I'm going to say sine 2x is 2, sine x, cos x, times the original cos x. Okay, cos 2x, so I'm going to stop. Alright, cos 2x I'm going to write in terms of sine. So I'm going to choose the 1 minus 2 sine squared x times by sine x. Okay, what have I now got? I've got 2 sine x times cos squared x plus sine x minus 2 sine cubed x. Alright, where's that going to take me? Well, if I look at it, I could probably take out a common factor if I put the first one and the third one together. I could take out a common factor of 2 sine x, and then I'm left with cos squared x minus sine squared x plus sine x. Alright, now okay, I don't think that's going to get me anywhere. I'm going to go back to the drawing board. Okay, so I'm going to go 2 sine x, and instead of cos squared x, I'm going to write 1 minus sine squared x plus sine x minus 2 times the sine cubed x. Okay? Alright, so now I'm left with 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. So at least I've got everything into sines, okay? Alright, have I got any like terms? Yes. 2 sine x plus sine x gives me 3 sine x minus 4 sine cubed x, okay? So I've added all my like terms together. And lo and behold, if I go back to the beginning, I can see that that is equal to my right-hand side.